Hello all, this is Milt Olson with the Maintenance Technology Systems. Here we are to demonstrate the basic functionality of our Vbox3 portable data collection device. So what you're seeing here is the main user screen on our Vbox3. It is a pull-up Windows application. Runs, you launch it off a Windows desktop. And anyways, we're going to just go through it. If you've already seen the MTS Explorer, we have a similar way here to select different possible customers as well as different departments. And then we have our machine list that we saw on the other part of that. Notice that we have all of the machines here, not just the ones that might have data on them. So this is designed to go out in the field and collect data from a triaxial transducer. You can see the picture of the triaxial transducer here, and mounts with a magnet. Generally speaking, we mount the transducer on the side with the cable orientation pointing down or up. And then we decode horizontal, vertical, axial. From that, if the side isn't accessible, we can go to the top, which is a different decode, or mounted on the end axially, which is a different decode as well. So that's kind of the basics of what we do here. Notice that this picture, we're able to actually take a picture of the transducer as it sits on the machine. This does two things for us. One, it helps out in our reporting arena. So when we send a report to someone, we can show them exactly where we took the vibration reading from. But probably more importantly is with this picture, the next time we come back to collect data on this particular point, we know exactly where to put the transducer, and we know how to orient the transducer so that we get consistency in our vibration readings from time to time as we go out and recheck these machines for predictive maintenance purposes. So along the left-hand side, we have our navigation buttons, our acquired data here in the middle, and we'll show you how that works here in just a moment. We have previous point and next point. Notice we can just click these and just go through the machine list, however we want to do that. And notice that the pictures update based on the machine that we've chosen. We can also skip to the next machine. It just goes one machine at a time. We go previous machine, go back up here to the top of the list. So that's our basic navigation there. Or we can simply select it from the list and whatever we want to do. The other thing to keep in mind is this department or machine list. As we collect data, it will actually move to the next point, which is a nice feature to have. It will show you the ability to do that and then move along. So it's a good way to just step through and take data in automatically increments. You can always back up and look at another point if that's what you would like to do as well. So that's that one. Now across the top, we end up with our machine information. The asset ID number can go in this field. It's editable. You can put whatever number we want there. More of a verbal description of the machine itself. Then a description of the measurement location, motor outboard, and basically pulls it from here. Motor inboard, compressor outboard, those kinds of things. And this is our transducer orientation. This field shows us the last time data was taken on a particular machine. Usually they're more current than that particular data. Then our shaft speed is listed up here in the right-hand corner. You'll notice that we've got a number 4 showing up. It actually will show us the number of averages or number of data sets that it's collecting. They're not necessarily averages. We're collecting a long time waveform is the goal here. These other buttons down here at the bottom are just to get to different data displays and so forth. So we are going to collect some vibration data here. We have just a single transducer, and we will attach that to one of our inputs, so that as we collect data, you can see some vibration coming through, and we'll do that. So here we go. We'll hit the Acquire Data button. It gives us 3 channels of vibration. Note that if I tap this transducer on my hand, we get one kind of vibration. And notice that it went ahead and stored that data set, moved on to the next one, and go back and look at that data if we so choose. There it is, as I've been tapping that on my hand. It fills in these overall numbers. Not very realistic, as it's not a real machine, and so forth. So we've got a little bit of a noisy drill. We're going to hook it up here and take our next data point, just so you can see some different data. So we'll move on there. We'll hit our Acquire Data button and start the drill. And as you can see, it records data throughout the time frame there. So go back to our previous point. You see how the vibration increased. We get a scale here. If we want to look at this data in the more detailed plot, we can go there. We can select our triaxial. Note the amplitudes are all the same on each scale. Nothing attached to these 2 channels, just this one showing up. We could also do a triaxial spectrum if we wanted to. We can increase the amplitude by dragging this bar repetitively up. We can eventually pull the data onto our display of interest. We can then drag this one, stretch it out horizontally. We also have a cursor we can put on our, to get readout of what different frequencies are. And that's the basic analysis of what we're doing here. So we exit that. Just one more thing to show you. We'll just hit this Tools button. Brings up this display. Shows you the basic setup for this machine. We can change any of these things. We've got our our database setup. We can select a machine, copy our data out to our jump drive, delete data. We'll test our cable connections, make sure they're working. Our transducer sensitivity just gives us access to change some of those things that become global settings for our data collector. So we'll hit cancel out of this, back to our main screen, and that is basically the